Hello, a pleasure day to everyone. Today we will discuss the aircraft ignition system maintenance and reciprocating engine. It is mainly focused on how the reciprocating engine works in order to help the system for its combustion. But still, I will explain it later. So for the contents of the topic, we have our learning objectives, to understand its function and maintenance of the ignition system reciprocating engine. And for introduction, we will discuss its significance in engine operation, the ignition system overview of reciprocating engine, to explain the spark generating process, and for major components and their function, to identify the ignition components, and the second one is maintenance and inspection task, to conduct the proper inspection and servicing procedures. And lastly, the common faults and troubleshooting, to diagnose and resolve the ignition system defects. So next is our learning objectives. Here we are going to have the explanation of the purpose of the function of the ignition system reciprocating engine, and outline the maintenance inspection tasks specific to ignition system reciprocating engine. And the third one is recognize the common faults, troubleshooting, methods in ignition system. And lastly, to emphasize the safety precautions and proper handling of ignition system components. So now let me give you a walkthrough of the ignition system. In reciprocating engine ignition system, regardless of the type, it must supply a high voltage spark to each spark plug in correct firing order. The spark plug must occur at a specific number of degrees before it goes down to the top dead center of the position. From here, from bottom dead, it will pushes the fuel and air mixture upward to the top dead center, and by that the spark plug will ignite. But here, let me explain more. So many reciprocating engines uses two separate magnetos, left and right, and two spark plugs per cylinder. And it is threaded into the cylinder head with the electrodes exposed to the combustion area of the engine cylinder. So, why does the reciprocating uses two spark plugs? We have two bases, because the first one, the main one, is for the redundancy of the system, for the better power, better ignition, and the second one is for backup. Yes. So if one magneto fails, the other can continue to operate, allowing engine to keep running through less efficiently. So for this slide 5, as we can see, this is the two types of magneto system in reciprocating engine that gives an electricity to the spark plug, as I've said, and that is to ignite the fuel and air mixture. For the first one, we have the magneto ignition system. For its explanation, the magneto engine system works mechanically and generates its own electricity. It sends spark to the spark plugs based on the fixed timing, and it doesn't rely on the aircraft's battery or whatsoever electronics. So it keeps running even the electrical system fails. On the right side, we have the full authority digital engine control, or the FADEC. So in FADEC, it is fully electronic, dissimilar with the magneto ignition system, which is mechanically controlled, or it works mechanically, the magneto ignition system. So the FADEC is computer controlled system. It manages fuel and ignition automatically, adjusts timing, and optimizes engine performance. It needs electrical power to operate and removes the need for manual mixture and throttle adjustments. So in real world aviation today, magneto system are still used the most, especially in general aviation piston aircraft like Cessnas, Pipers, and many training aircraft. Like for example, here in magneto ignition system, we have the Cessna 152 it is magneto ignition, the Cessna 172 NS, no 172S, sorry, 172N and 172P. It is also magneto controlled. And lastly, the system 182. So here in FADEC, we have Cessna 172 RS with continental horizontally opposed 360 AF, and Cessna 172 JTA, a diesel version, and the Cessna 182 Turbo, the diesel conversions. And FADEC is used in growing and in modern engines, but still common in traditional piston aircraft, and it is used in newer designs because of its high performance engine and turbines. And lastly, we have the battery ignition system. For simplest explanation, it is an ignition system that uses the aircraft's battery and alternator to create the spark needed to the engine to run. Like, for the simplest way again to understand it, we have this battery supplies the electrical power, and then that power goes to the ignition coil, which boosts the voltage, and then the boosted voltage goes to the spark plugs, creating spark. So then the spark plugs ignites the fuel and air mixture in the cylinder.
So, for the purpose of ignition system in the reciprocating engine, to ignite the fuel air mixture in each cylinder using a high voltage spark, and to deliver the spark at the correct time for efficient combustion, and also it operates independently of the aircraft electrical system using magnetos to provide redundancy through a dual ignition system for safety and reliability, to maintain a consistent performance under varying speeds, temperatures, and altitudes. And the ignition system's job is to make a spark that burns the fuel and air mixture inside the engine. This spark makes the piston move, produces power, and it also makes sure the spark happens at the right time so the engine runs smoothly and efficiently. So for the next one, we have the main components of ignition system. The first one is the magneto. The magneto is a small generator that produces electricity for ignition system, and it doesn't need a battery, and it creates the high voltage needed to make a spark by using magnets and coils. And the next one, we have spark plugs. This part, it delivers the spark into the engine cylinder. The electricity from magneto jump across the spark plug's gap to ignite the air and fuel mixture inside. In short, the magneto, it makes the electricity, and the spark plug uses the electricity to make a spark that burns the fuel. And for the next one, we have the ignition switch and the ignition harness. The ignition switch, it is the control that turns the engine system on and off. When you turn the key or switch it on, it allows the electricity to flow from the magneto or the battery to the ignition system so the engine can start and run. Turning it off stops the flow of the electricity and shuts the engine down. While the ignition harness, it is a set of wires that connects the magneto to spark plugs, and it carries the high voltage electricity from the magneto to each spark plug so sparks can be made in the cylinders. So in short, the ignition switch turns the engine system on and off, while the ignition harness delivers the electrical power from the magneto to the spark plugs. So you do have here the next component, which is the distributor, and the condenser, which is the capacitor. So for the first one, the condenser, it is a part of the ignition system that sends the high voltage electricity from the coil or magneto to correct the spark plugs at the right time, and it also distributes the spark to each cylinder in proper firing order so the engines run smoothly. So for the condenser, also called as a capacitor, it is a small electrical part connected to the distributor, and its job is to prevent sparking or arcing the contact points to help store and release the electricity quickly. And it makes the ignition system work more efficiently and keeps the point from wearing out too fast. So the distributor sends the spark to the right spark plug at the right time, and the condenser, or while the capacitor, it helps the control the electrical flow and protects the system from any damages. So for the main components in the ignition system, this is the last part. The breaker points, or the cam, also called contact points. It is a small electrical contacts inside the distributor. They open and close as the cam turns. When the points are closed, electricity flows through the circuit. When the cam pushes them open, the flow stops suddenly, which causes the ignition coil to release a high voltage spark to the spark plug. And the breaker points open and close to control the timing of the spark, while the cam makes the breaker points move at the right time moment for each cylinder. And for the next slide, we have Mr. Hermogenes.
Good day everyone. Today, I will be explaining the operation sequence of a reciprocating aircraft ignition system, also known as the magneto-ignition system. This system is responsible for producing the spark needed to ignite the fuel-air mixture inside the cylinders. The first step would be the crankshaft rotation. The process begins with the crankshaft rotation. As the engine crankshaft turns, it drives the magneto through a gear mechanism. This means that the magneto is mechanically connected to the engine, allowing it to operate without relying on the aircraft's battery. The next would be the magnetic field generation. Inside the magneto, there is a rotating magnet. As it spins, it creates a magnetic field around the primary coil. This changing magnetic field is essential because it forms the basis for generating a high voltage electricity later in the process. Next is the breaker points operation. When the magnet reaches a certain position, the breaker points open. This sudden opening interrupts the primary current, causing the magnetic field to collapse rapidly. That collapsing magnetic field then induces a high voltage in the secondary coil, which is eventually sent to the spark plugs. Now, let's continue with the remaining steps of the ignition sequence. The next would be the voltage induction. When the breaker points open, the magnetic field inside the magneto collapses very rapidly. This sudden collapse induces a high voltage in the secondary coil, which is strong enough to jump the gap at the spark plug. Then, the voltage distribution. Next, this high voltage electricity is sent to the distributor rotor. The rotor directs the voltage to the correct spark plug, depending on the engine's firing order. This ensures each cylinder fires at the proper time. Then the spark plug ignition. Once the voltage reaches the spark plug, it jumps across the electrodes, creating a spark. This spark ignites the compressed fuel-air mixture inside the cylinder, producing a combustion. And lastly, power and continuous operation. Finally, the burning mixture pushes the piston downward, creating power for the engine. This engine power keeps the crankshaft rotating, which continues turning the magneto, meaning the entire process repeats continuously as long as the engine is running. So overall, the ignition system is completely self-powered. It does not rely on battery. Now, let's move on to troubleshooting. This table shows some common ignition system problems and their possible causes, and the corrective actions. First, rough engine operation. This usually happens when the spark plugs are fouled or worn out. To fix this, we must clean, regap, or replace the spark plugs. Next, if there is an unusually low RPM drop during a magneto check, it often indicates a weak or faulty magneto. The solution is to inspect and repair or replace the magneto, and also to verify its timing. For engine misfire, a common cause is a loose or damaged ignition lids. To correct this, we simply tighten or replace the ignition harness connections. Lastly, hard engine starting is often due to incorrect ignition timing or weak spark. To fix this, we must verify and adjust magneto and condenser timing, and check the breaker points. Let's continue with more troubleshooting procedures related to ignition system. When we observe an uneven or abnormally high magneto drop during the run-up check, it usually indicates a faulty spark plug or a defective ignition lid. To correct this, we replace the spark plug or ignition lid and retest the magneto drop. Then, engine runs on after switch off. If the engine continues running even after ignition is turned off, this normally means there is a grounding problem or ignition switch fault. The proper action is to inspect the switch circuit, check the pilot grounding, and repair any wiring issues. Then, finally, when there is no spark at all, the most common causes are an open circuit or a failed magnetocoil. The recommended solution is to perform continuity checks on the ignition circuit and replace any failed components. In summary, knowing the symptoms and understanding their likely causes allows technicians to diagnose the problems quickly and accurately, ensuring safe and reliable engine operation.
But take note, always ensures any repair follows the engine manufacturer's maintenance manual and handbook notes, the FAA handbook or IPC, Illustrated Parts Catalog, is generalized. Differences exist depending on the engine models. And for our references, we have 4 references. And that's the coverage of our presentation for APU ignition and starting system. Thank you.